Okay, section 1-2 for finite math. In this section, we'll continue with what we were doing on straight lines. And in this particular, we're going to start talking about the slope and how to find it and how to use it. So a lot of this I've copied straight out of the section, but I put some of my own flavor a little bit to it. Definition: given a non-vertical line L with equation of y equals mx plus b, the number m is called the slope of L. That is, the slope is the coefficient of x in the equation of the line. The equation is called the slope-intercept form for the equation of the line. Again, most of that you've probably seen before. We're just trying to put a little structure to it. So, finding the slope of a line from its equations, what we want to do is find the slope of the lines given these equations. So, remember these are y equals mx plus b. So if y equals 2x plus 1, m stands for slope. Slope is 2 because that's the number right there, the coefficient of the x. And this one, y equals negative 3/4 x plus 2, your slope is negative 3/4. On this one, y equals 3. Trying to be tricky. Think of that one as y equals 0x plus 3 if you want to. So now you know the slope is equal to 0. Okay, and then when you have one like this is not slope-intercept form. So what you want to do is put it in a slope-intercept form. So I'm going to take and rewrite this. I'm going to add the 8x. I'm going to bring it to the other side so that it becomes a positive 8x plus 4. And then if I divide by 2, y is equal to 4x plus 2. And now when you look at it, your slope is equal to 4. Okay. So think of it this way. This is the way I look at slope. I use this definition. In layman's terms, slope is how much a line goes up or down as you go left or right. So if you have a line that's going up as you go left or right, that's positive slope. If it's going down, that's negative slope. Here you got a line that doesn't do either one. It doesn't go up or down, so that's 0 slope. And then a line that goes straight up and down, well, that doesn't have slope. And if you go back to my definition, it's how much a line goes up or down as you go left or right. This line doesn't go left or right, so it does not have a slope. It's undefined. Now, let's look at it a little differently too. Let's say I've got here's my coordinate axes. So I got an x-axis and a y-axis. If I had a line here that was exactly 45 degrees, the slope of that line is equal to 1. If I split the difference here, that slope would be 1/2. Slope going straight across would be 0. If I came back up here, let's say I split that difference, that slope is equal to 2. So the bigger the slope, the steeper the line. And as that line moves around, so I went 1/2, 1, 2, 3 is going to be about here, 4, 5. Better yet, let's do this. Slope of 1/2, 1, 2, 3 is going to be about that steep right there, 4 steeper, 5, and that's going to keep getting steeper and steeper and getting closer to that y-axis, but it'll never quite get there. If it did, it'd be straight up and down, and therefore you would not have slope. Okay, so what if the line went down here? Well, that's going to make it negative. So if I came down here, that slope would be -1, that 45 degrees. Okay, this would be a slope of negative 1/2. There would be a slope of 2, and so on and so forth. And I'm sorry, negative 2. So the bigger the negative, the steeper going down it's going to be. Okay, I think you know enough about slope at this point. Page 2. In the book, they say an alternative definition, but basically all it is, it's this formula, and you've seen this before. If you're given 2 points, you can find the slope by taking y2 minus y1 over x2 minus x1. I've got 3 examples down here. I want to find the slope of a line that goes through those 2 points. Okay, so, you know, if you're new to doing this or you're not real good at it yet, I always just label that one as x1, y1. That's the first point, so it's got the subscripts of 1. The second point has subscripts of 2. So you got x sub 2 and y sub 2 there. So the slope, m, always use m for the slope. Okay, it says y2 minus y1 over x2 minus x1. So y sub 2 is 6. Y sub 2 is 6. Y sub 1 is 4. All I'm doing is taking those numbers and plugging them in. And on the bottom, you got x2. x2 is 2, and x1 is 3. So I got 6 minus 4 on the top is 2, and 2 minus 3 is negative 1. So let's just call that negative 2. Second one down here. Okay, so slope on this one, I'm not going to write the formula down. But here's x1, y1, same as that was, x2, y2. So it's going to be 6 minus 1 on top. And on the bottom, it's 8 minus 5. There's a lot of times people know the formula, and they go to put the numbers in, and they get the numbers in the wrong places, and that's why they miss it. So really work on making sure that you have the numbers in the right places. 6 minus 1 is 5, and 8 minus 5 is 3. 5/3. And just keep it like that. Don't write that as 1 2/3. It's better to leave it as what they call an improper fraction. Okay, and then the last one I have down here, so that's negative 3 minus 5. I'm just going to go ahead and put negative 8 over here. And on the bottom, it's going to be 6 minus negative 2. 6 minus negative becomes plus. 6 plus 2 is 8. Positive 8. So I got negative 8 over positive 8. That slope's going to be negative 1. Okay. The next thing they talk about, and I've never really used this before, but it's okay, the steepness property. So let the line L have a slope of m. If we say, if we start, that's supposed to be a t there. If we start at any point on the line and move 1 unit to the right, then we must move m units vertically meaning up or down, in order to return to the line. If m is positive, we move up, and if m is negative, we move down. Okay, let me show you what that means. Let's say we just have a line here. So if I start at any point and I go 1 unit that direction, it's 1 unit to the right. And then from that point, let's say I go straight up. That distance is whatever the slope is. That's all they're saying. And if the line went the other way, pick any point. If I went 1 unit this way, and then I'd have to go down m units. Okay, we're going to use that in a little bit. Page 3. Okay, we're going to use the idea of steepness, but more than that, we're going to use this, and you've seen this before, the slope-intercept form. Okay, we know That's y equals mx plus b. I talked about that in the error page. Where m is the slope and b is the y-intercept. The really nice thing about slope-intercept form is that you can graph a line really easy. So let's look at this one here. I got y equals 2x plus 1. I know from that m is equal to 2 and b is equal to 1. The b equals 1. I'm going to switch pins here real quick. With the graph, it'll show up a little bit better. On the y-axis, remember here's the y-axis, that's the x-axis. On the y-axis, I want to locate 1. So when I do, it's right here. That's what the intercept tells me. Okay, now the slope is 2. Think of that as 2 over 1. That means we're going to go over 1 and we're going to go up 2. And that gives me a new point. Now, before I draw the line in, it is good to spread that out a little bit. So I went over 1, up 2. Do it again. Over 1 and up 2. That gives me another point. And I could keep going. And what you'd like to get on that is when you draw your line in here, that's where your straight edge comes in. I expect these lines to be straight if you're going to turn it into me. If you don't spread these points in, then sometimes this line, sometimes it's not right where you want it to be. It might be a little bit this way or a little bit that way. The wider you can take those points out, the more accurate your line is going to be when you draw it. More on that as we come. Okay. On this one, it says y equals negative 3/4 x. So the slope is negative 3/4. And my intercept is the plus 2 at the end. So on the y-axis, I'm going to locate the 2. You always start with the y-intercept. And this says negative 3 over 4. That means down 3 over 4. Down 1, 2, 3. And 1, 2, 3, 4. Look at your 2 points there. Those are your 2 points that's going to determine the line. If you could stretch that out, that would be great. In this case, we're just going to go ahead and draw it in there. I made my point, so I'm not going to do that. There you go. Okay, going down to my third example. Now, y equals 3. Now remember, you could think of that as 0x plus 3. Remember I did that on the other page? Same problem really. But now you know your slope is 0 and your intercept is 3. So on the y-axis, we're going to find the 3. And a slope of 0. A slope of 0, remember that's flat. That goes straight across. So when I draw my line, that's what it looks like. That's a slope of 0. So I had a positive slope, a negative slope, and there's a 0 slope. Okay, now look at D. We did this before. This is not in slope-intercept form, so we're going to put it in slope-intercept form. So if you remember, it's the same problem I did on the other page, so we've already got done. So you can probably just look at this and not have to write it down because you got it somewhere else. So we're going to put the 8x on the other side. Then we're going to divide by 2. So it becomes 4x plus 2. So my slope is 4 and my intercept is 2. So we find the intercept, which is right here. That's going to be 2. And a slope of 4, that's like 4 over 1. That means up 4 over 1. So from here, I'm going to go up 1, 2, 3, 4, and over 1. I'll put another point. And from geometry, you know, 2 points determine a line. So we've got a pretty steep line that goes up, and that's what that 4 tells you. Okay, let's go to the next page. We're moving right along. Okay, I put this together. There's actually 3 forms of writing equations of lines. You won't find this in the book, but I think it might be helpful for you. And I think it'll make sense to you. But there's general form, and sometimes they'll call that standard form. Depends on what book you pick up. One book will call it standard, and one book will call it general. But the bottom line is you got ax plus by equals c. Actually, I think in section 1 they had cx plus dy equals z. It doesn't matter. They're just constants you're putting in as coefficients. But a, b, and c are constants, and a and b are not both 0. Okay? A has to be positive, and they all have to be integers. So when I did this other problem on the other page, that was actually, this problem here, that was actually in standard form or general form, depending on what you call it. And the others were in slope-intercept. Slope-intercept's a lot easier to graph. I like to think of it this way. When you think of a person's name, maybe somebody's name is William Arthur Smith. That's their formal name. But nobody calls him William Arthur Smith. They might call him Bill, because Bill is easier to work with. Okay, well, your general form is your formal name, whereas slope-intercept form might be the name you're called. It's easier to work with. Okay, and we already talked about slope-intercept form anyway. Y equals mx plus b, where m equals slope and b is y-intercept. Now there's one other that I'm going to put out here. It's called point-slope form. And it's y minus y1 equals m times x minus x1. That's the same thing as your slope formula, except I multiplied through. Okay? We're going to use that here in a little bit. And that you'll never leave an answer in this form, but we will use this form to help us get to an answer. Okay, so let's go down here. I've got several examples. 3 of them I want to find the equation of a line, and this isn't too bad. This says find the equation of a line for the given information, and in this one, the line has a slope of 1/2 and a y-intercept of 3. Well, this one's easy. Y equals m is 1/2 times x plus 3. There's no work to that one. Everybody could get that. Okay, what happens when it gets harder? Well, in my second one here, the line has a slope of 3 and goes through the point of 1, 2. So I know m is 3, and think of this one as x1, y1. And we're going to go back up and we're going to use this. This is where point slope comes in. Point slope says y minus y1 equals m times x minus x1. And in this one, I know m is 3, so I'm going to put that in there. I also know that x sub 1 is 1, so that goes here. And y sub 1, so y sub 1 is 2, so I got y minus 2 over here. All I have to do now is, I'm going to go ahead and put that in slope-intercept form. So y minus 2 equals 3x minus 3. Y equals 3x, and I'm going to add that 2 over here, so negative 3 plus 2 becomes negative 1. That's my answer. in slope-intercept form. So to get that, I started with point slope. I plugged in what I knew, and then I simplified that down. Okay, one more of these. And I actually feel like I should do a couple of each one, but I think I'm just going to keep it simple, and we'll see what happens. Okay, so now I want to find the equation of a line that goes through these 2 points. What you'll notice I don't have on this one is the slope. So we're going to start out and we're going to find the slope first. So remember the slope, it's y2 minus y1. So y2 minus y1, that's 4 minus 1 on the top, and 3 minus 2 on the bottom. So that's going to be 3 over 1, so m is equal to 3. Then once you get to this point, you got the slope, and you could use either one of those points like I did in example B up here. So let's say I'm going to use this guy. I always take the easiest one. So it's y minus y1 is 1 equals, the slope is 3. All I'm doing is using that point slope form, times x minus 2. Okay, y minus 1 equals, now I'm going to distribute, so it becomes 3x minus, and 3 times 2 is 6. Y equals 3x, and when I add the 1 over here, now it's going to be 3x minus 5. So y is equal to 3x minus 5 on that side. And that's how you find equations when you're given certain things. So the big thing in this section is knowing slope and how to use it, being able to graph lines, and then if I give you certain characteristics, you should be able to come up with the equations. Okay, just a little bit more. Here's 2 more concepts: parallel lines and perpendicular lines. When it comes to slope, parallel lines always have the same slope. So if they're parallel, whatever the slope of one line is, the other one's going to be the same. Perpendicular lines have slopes that are negative reciprocals. I'm going to come back to that in a second. Let's talk about parallel. So I want to find the equation of a line that's parallel to this line that goes through that point. So what we're going to do, we're going to use this equation right here to find slope. Okay, so 4x plus 2y equals 8. 2y, I think it's the same one. It's the third time I've done this. No, I didn't. Minus 4x over there plus 8. And when you divide by 2, y is going to be equal to negative 2x plus 4. This tells you the slope of the first one line, which I'm going to call M1, is equal to negative 2. So remember, you're given one line, this line here, we're finding the equation of the other. So the slope of this first line is negative 2. What's the slope of the other line going to be? Well, since it's parallel, it'd be the same. So now I'm going to do this, and I'm going to say M2 is equal to negative 2, because those have to be the same. All right, now, point slope. Remember, I'm going to put the formula down again. Y minus y1 equals m times x minus x1. x1 and y1 are up here, and my slope we now know is negative 2. So let's plug in. So y minus y1 was 6 equals, my slope was negative 2, and it's x minus x1, which is 5. Y minus 6 equals, and I'm going to distribute. Remember, whatever's on the outside, you got to multiply by both of them. So it's going to be negative 2 times x is negative 2x. And negative 2 times negative 5 becomes plus 10. Always make sure that sign is correct. There's a lot of times say, well, if I have a negative here, I'm supposed to have a negative here. No, you're going to take that times that. So a negative times negative makes that positive. So y will be equal to negative 2x, add the 6 over here, and that becomes 16. That's my answer. Okay, here's my last example of the day. Now we're going to talk about perpendicular. This is going to be the same problem, except that was parallel, that's perpendicular. You'll notice I've still got the same equations. Okay, so I'll go ahead and put it over here, but 4x plus 2y equals 8. I'm doing the same thing I did up here. 2y is going to be negative 4x plus 8. And y will be equal to negative 2x plus 4. Same thing I had up there. And we know m1 is equal to negative 2. What's m2 equal to? Well, it's not going to be negative 2. So let's go back a second. We were talking about there at the top, it says perpendicular lines have slopes that are negative reciprocals. So let's talk about negative reciprocals. Negative means opposite. Reciprocals means you're flipping it over. So if I had one number of 2, the reciprocal would be 1/2. The negative reciprocal would be negative 1/2. If this is 4, that's negative 1/4. If this is 1/2, then that's going to be 2 over 1, which we would write as 2. I'm sorry, negative 2. If this is negative 1/2, then I'd flip that over and take the opposite. That makes it positive, so that's going to be positive 2. If this was, say, negative 3/4, I flip it over and take the opposite, and that becomes 4/3. So that's what they're talking about with negative reciprocals. Okay, so back to the problem. So I did all this, and I found the first slope to be negative 2. So the negative reciprocal of negative 2 is going to be positive 1/2. Now we go to work. Y minus y1 equals m times x minus x1. Here's x1, there's y1. So it's going to be y minus 2 equals, my slope I'm going to put 1/2 in, and x minus 3. So y minus 2 is going to be, 1/2 times x, and 1/2 times a negative 3 becomes minus 3 over 2. Okay, so now we're going to have to add 2 to that side. We got to add 2 to that side. Those drop off, and you end up with y equals. And I'm going to have 1/2 x. Now, many of you guys are going to have trouble with fractions, so let me come down here. What I'm really doing is taking negative 3 over 2 plus 2. Think of that as 2 over 1. And whenever you add, you got to have a common denominator. The common denominator here is going to be 2, which I've already got a 2 on the first one, so that's negative 3. To make that into a 2, I multiplied by 2. So 2 times 1 gave me 2 on the bottom. 2 times 2 on top gives me 4. Now, when you look at it this way, 4 over 2, 2 over 1, or 2, they're all the same thing. So now you got negative 3 plus 4 is positive 1, and it's over 2. Okay, so we're going to say plus 1/2, and that's my answer. Y equals 1/2 x plus, there's no mark there, plus 1/2. Okay, that should be everything you need to know in section 1-2. Remember, homework's always due on Sunday night, so you should get a good start on this one. And in this week, I believe 1-3 is following right behind, so both of those will be due on Sunday. Always follow the assignment list that I have, and it's the first thing you're going to find in your resources. I think it's I tried getting it the first thing. If it's not, it'll be down below. But follow that as for your assignments, and always make sure you have your dates correct. Okay, see you at the Zoom meeting. If you have questions or anything, let me know, and we'll see what happens. See ya.